Jai Hind to all. Myself, Dr. Yogendra Prajapati, Assistant Professor at Ajay Kumar Garg Engineering College, Ghaziabad. Today, I am going to teach a very important topic, how to any NFA are convert into a DFA. That is the conversion of the NFA into DFA conversion. Now, what is the NFA? NFA, that is very simple, non-deterministic finite automata. That is stand for the finite automata, and D stand for the deterministic. Same, that is a finite automata. What is the deterministic and non-deterministic? It means path is defined. What is the meaning of path is defined? Simply with the help of single inputs, if machine can move a fixed state, that is one state, it means path is defined. If with the help of the one input, machine can move more than one state, it means path is not defined. Machine cannot be defined. Say, that is the basic difference between NFA and DFA. Now, these are the mathematical definition of the non-deterministic finite automata. In the mathematical form, the non-deterministic finite automata represent into a 5 tuples. Now, that is a Q. That is very simple. Q is a set of states. Now, what is the sigma? Sigma is a set of alphabets. It may be AB or it may be 0, 1. Now, that is the transition function. Now, this one is most important because this 1 marks question asked in the GATE examination, what is the transition function of the NFA? Now, that is the 2 to power Q, where 2 is a number of inputs used in the machine and Q is a number of states. Transition function. Now, that is the initial state, that is also the subset of the Q, it is set of initial state. F is a final state that is except all the stated. Now, 2 to power Q is a set of subset of Q and sigma. Now, that is the set of input. It include also the epsilon. It means the null string can also accept in NFA, but in DFA null string is not allowed. It means with the help of the any inputs, machine can move on any state, but in NFA without inputs machine can move. That is the one basic difference between DFA and NFA. Now, we are taking the very simple example, 3 or more point we discuss. NFA is an incomplete machine. NFA, non-deterministic finite automata, without input we can also move, and with the help of single inputs machine can move more than one state. That is the basic definition. It means with the help of the inputs machine can move on Q0, and with the help of the one machine can also move on the Q1. That is the non-determinism. It means with the help of single input machine can move in 2 directions. The first direction is that is a Q1, and the second direction is that is the Q1 and Q0. The similar here also with the help of now epsilon NFA is also allowed. Now, here is there is a 2 inputs 0 and 1, and here is also a 2 inputs, and here is a 0 and 0, and some inputs are not allowed in also NFA. Now, these are the transition table of the NFA. That is very simple. Now, Q0A, that is machine could move on the Q0, and Q0 on B, machine can move in 2 states. That is the non-determinism. That condition is occurring non-determinism. Q1A, no state, that is also known as a non-determinism. Now, Q1B, that is also known as the Q2, and Q2, this is also a non-determinism. Now, this is the transition table. Then, how we can convert any given machine into NFA into DFA? That is very simple state. Now, what is the simple state? Now, we start from the initial state. Now, transition A and transition B. Now, state start from the Q0, and what is the state? Q0 and Q1. Now, what are the new 2 state occurs? That is Q0 is an initial state. Now, new state is that is Q0 and Q1. Now, Q0 and Q1 become a next state. That is the step by which we can convert any non-deterministic into a deterministic finite automata. Now, Q0 Q1. Now, Q0 Q1. Now, here is a Q0. Now, here is a that is Q0, Q1. It means Q0, Q1 and Q2. The next new state, that is Q0, Q1 and Q2. Now Q0, Q1 and Q2, that is the next state of the DFA. Now on A transition, Q0, Q1 and Q2, that is again Q2. And now here is a Q0, Q1 and Q2. Now this one is the transition table of the DFA, and now this one transition table of the NFA. That is very simple. The first column we write as it is, and which one state is new, consider as a next state. This is the method by which we convert any NFA into a DFA. For the better understanding, we take another example how to convert any NFA to DFA. Here is another example. What is the step? First, we draw the transition table of this given table. Now, how many steps? That is state 1, state 2, state 3, state 4. Now, how many inputs? Inputs is 0 and 1. Now, this is transition table of the NFA. Now, on one state 0, we move into the state 2. From one state, move one, give the 1. Now, this is the no state. Now, on stage 2, for 0, no transition, and for 0, on state 2, no transition. Now, on state 3, what is the transition? For the 0, that is the 4, and for the 1 transition, not. Now, on state 4, for 0, that is the state 3, and 1, that is the no state. Now, on state 2, for 1 transition, that is the 4. Now, here we observe that epsilon are occur. Then, first we remove the epsilon into the NFA. Then, we find the epsilon closure. Now, what is the epsilon closure? Epsilon closure of all state. That is very simple. 1, 2, 3 and 4. What is the epsilon closure? With the help of epsilon closure, that state move how many state? Yeah, reached how many state? That all state is known as the epsilon closure. Simply, with the help of epsilon, state 2 reached how many state? Then that all state is known as the epsilon closure of that all state. So, by default 1, 2, 3 and 4, the epsilon closure of the all state. Now, with the help of epsilon closure, one state can move on state 3 and also move on state 2. Now, on 2 state, with the help of epsilon, what can move? No movement. With 3, we can move state 2, and 4, no state movement. Then we find the transition table of the NFA using the epsilon closure. Now, this table are not working because in this NFA have the epsilon closure. Now, we check the transition function of the state 1, not 1, the closure of the 1. It means that is 0. Now, this is the 1. On our state 1, it means we check the transition of 1 on 0 with state 1, 2 and 3. Now, we check the 0 transition. Now, for the 1, it is that is the state 2. For state 3, we move on state 4. and for 2, 0, no movement. It means 2 and 4. Now, what is the closure of 2 and 4? That is 2 and 4. It means here is a 2 and 4 state for the one transition on 0 input. Similarly, 1, 2, 3, we check the transition of the 1. Now, from 1 state 1, no. For 2 state, that is the 4. For 2, 1, and that is the again 1. Now, 3, 1, no transition. It means here 2 and 4. Now, here again 2 and 4. Similarly, we find the transition of 2 on 0 and 1. Now, the transition of the 2 for the 0, no transition, and for the 1, that is the 2 and 4. Similarly, 3. Now, we check the closure of the 3, that is 2 and 3, and we check 0, and similarly 2 and 3, we check the transition of the 1. Now, on 2, 3, 0, now that is the state 2, 0 transition not available, and on 3, 0 transition, that is the 4. Now, here is a 3 and is a 4, it means here is a 4. Now, 2, 3 for 1 transition. Now, 2, that is the 4, and 3, 2, that is the 2 and 4. 1 transition, and 3, here is a no transition is here for the 1. Now, here is a 2 and 4. Again, we check the for the state 4, and here is a only 4. Then we check the on 4, 0 transition, that is the 3. 4 on 0 transition, that is the 3, and 4 on 1 transition, no transition available here. Now, this is the actual transition table of the NFA after eliminating the epsilon. We eliminating the epsilon using the epsilon closure. Now, we can convert this NFA into a DFA with the previous algorithm or with the previous steps. Very simple. Now, this is the NFA. Now, that is the very simple. What is the DFA? Now, here is 0 and 1. Now, state 1, and here we simply write 2 and 4, and here simply write 2 and 4. Now, what is the new state occurs? A new state is generated, that is 2 and 4. So, what is the next state? That is 2 and 4. And on 2 and 4, we check the transition of 0 and the transition of the 1. Now, this is the 2 and 4. What is 0 transition? That is the 3. It means 3 new state are occur. So, 3 is the next state. And what is the 2 and 4 on 1 transition? Again, it is a 2 and 4. What is the next state? That is the 3. So, on 3, we check the 0 transition, that is 4. It means 4 is a new state, and on 1, that is 2 and 4. So, 2 and 4 already we can use. Now, what is the next state? New state, that is the 4. Now, on 4, 0, that is the 3. On 4, 0, 1, that is the 5. Now, what is the new state? New state is 5. So, 5, that is the 5, and that is the 5. Now, this is the method by which we convert any NFA to DFA. For the better understanding, we take another example. Now, this is the method by which we convert any NFA into a DFA. I think, yes, this is another example by which we convert any NFA into a DFA. So first we check it is a NFA or not. Now on the 0 single state, 1 move on the 1 state. Now here 0 we move on the Q1 state and 0 we move on the Q2 state. It means that is the NFA, because with the help of the 0 machine can move in 2 state. So this is the NFA. It means there is the need to convert this machine into a DFA. The same procedure, first we we construct the transition table of the NFA and we follow the same rule by which we can convert this machine into a NFA. Now the very simple, we can simply, how many state here? Now transition is 0, 1, now state is a Q0, that is the Q1 and that is the Q2. Q2 is your final state. Now on Q0, that is the Q0, that, and 1, that is the Q1 and Q2. Okay. Now on Q1 0, that is the Q1 and here is a Q1 and Q2, and for 1 that is the Q2. Now Q2 that is the, for the 0, that is the Q1 0 and Q0. Now for the 1, yes, for the 1 it can be move on the Q1 and 1, any transition here? Not, only one transition is here. Okay. Now this one is the transition table of the NFA. Now with the help of this transition we can convert the machine into a DFA. Now that very simple. Here that is 0, that is 1, and write the same column as it is Q0 and Q1 and Q2. So how many new state are occurs? Only one state. Now Q0 on 0, that is Q0, only Q0. Okay, it's right. Now how many new state are occur? That is Q1 and Q2. So now Q1 and Q2 is your next state. Now Q1 and Q2, Q1 and Q2, this one. So Q0, Q1 and Q2. Now Q0, Q1 and Q2. Now this state, new state, we consider as a next state. Now Q0, Q1 and Q2, Q1 and Q2, here is a Q1, Q2. So now Q1 and Q2, it is not a new state because this is already considered. Now next one is that is Q0, Q1 and Q2 is your next state. Now we check the transition on 0, transition on 1. Now here is a Q0, Q1 and Q2, same Q0, Q1 and Q2. Now here is a 1, Q1 and Q2. Now Q1 and Q2. Now no one new state are generated. So this one is a transition table of the DFA. Now this is the very simple method by which we convert any machine into a NFA into a DFA. Now this one, this is the transition table. Now this one is the method. This one is a method, same one. This is here. Now where is the final state? Now this one is the final output. Now this one is a one state, Q0, Q1 another state, and another state is a Q1. Now this is the final output. Now we take the another example by which we simply this is the NFA. We simply draw the transition table A. Now here is a B. Now here is a Q0, Q1 and Q2. Now on Q0A, we move on Q2 and A, that is the Q1, Q2, and B, no transition. Now here is a null. 5. Q1A, no transition. 5. Q1B, no transition, phi. Now Q2A. Now Q2A, that is the Q1, and Q2A, that is again Q2. Now Q2B, that is the Q2, only this. So now this is the transition table of the NFA. And using this table, we can draw simply, construct the transition table of the NFA. Now, that is the A, that is the B. Now, here is a Q0, here is a Q1 and Q2, here is a phi. So, next state, that is very simple, Q1 and Q2. Now, Q1, Q2, here is again Q1 and Q2, and now here is a phi. Next state is a phi. Now, phi is a phi and phi. Now, this is the transition table of the DFA. Yeah, this is the NFA machine. This is the DFA machine. That is very simple. Some more interesting topic we cover into the next lecture of the finite automata and formal language. Thank you.